Hi, and welcome to the next video from the trigonometry section on the Year 2 A-level course. In the last video we looked at how we add together two trig functions, for example a sine plus a cos, and saw that they combine just to make a single function that is essentially a stretch and a shift of either our basic sine function or our cos function. We looked at how we used addition formulae to be able to identify the size of those stretches and shifts. All of that means what we're going to do today is have a look at how we can use those, and in particular start thinking about minimum and maximum values for expressions. So here we go. There's a big old looking question. We've got a function q of theta, which is 12 cos 2 theta minus 5 sine 2 theta, and we're told we can write it in the form, there it is, r cos 2 theta plus alpha. Okay, I'm not going to worry about that, so let's just do part A to begin with. Let's start off and let's just find out the value of r and alpha, and we'll worry about all the rest of it once we've got part A done and out of the way. So here we go. Find the value of r and alpha. Again, our standard setup is we equate our expression, our original expression, to the expression that's been suggested, which is this r cos 2 theta plus alpha. Notice in this one I'm using an angle of 2 theta here, so this one here is 2 theta also. And then we need to expand out or replace this with the addition formula for cos. So that would be cos 2 theta cos alpha minus sine 2 theta sine alpha, all multiplied by r. And you'll notice the reason that that one was chosen is because that matches the structure of the original thing, and in particular it's the minus sign, just kind of gives us something that's the same here compared to over here. Now we've got to do some equating. So here we've got 12 equals r cos alpha, and then we've got also 5 equals r sine alpha. And so here comes our triangle. There we go, that side is 12, 5, there's r, so that gives us straight away our Pythagorean triple. R is 13, and then alpha tan to the minus 1 of 5 over 12, and so we've got our two values, the value for r and the value for alpha. That one is pretty much straightforward, same every single time, initial setup, same structure. Once you get into the routine, I lay these out the same way every single time. I basically do what you just see on the screen, and that gets me to the answer every time. That's pretty much 4 marks sorted on the exam. Okay, let's now get into the playing around with this thing. So I've got my expression, and we've got the answers here. There are two values, r was 13 and alpha was 22.6. And it says, hence solve the equation. Now clearly this bit here, this 12 cos 2 theta minus 5 sine 2 theta, that's our original expression. So what we're going to do is simply replace that with our new expression. And now it's just a case of solving it for cos. So let's take the 13 across. Cos to the minus 1 of a half gives us 2 theta plus 22.6. So cos to the minus 1 of minus a half is 120. And clearly we've also got 240 there as well. And then it's a case of just doing the sorting out there. And we end up with our two values, 48.7 and 108.7. And on we go. Part B sorted. What's part C saying? Okay, so it says express 24 cos squared theta minus 10 sine theta cos theta in the form a cos 2 theta plus b sine 2 theta plus c, where a, b, c are constants to be found. That's a bit of a mouthful. Okay, so what should we do? Let's start off with our expression, and we've got to do some mucking around with that. The first thing I'm spotting from there is that this thing is in terms of just a single angle. Sorry, theta. This one is here is in terms of 2 theta. So we've got to kind of change the angle, and I think the way we're going to go about this is the double angle formula. So that bit there's looking familiar. The sine theta cos theta, I know that's part of sine 2 theta. So let's see if we can do something with the cos squared. And I think what I'm going to do there is go via cos 2 theta. So you might know these off by heart. I tend to rework them. So we've got that. And again, I'm just splitting off the right side of my page, doing a bit of scribbling around. So cos 2 theta is 2 cos squared theta minus 1. Let's now rework that and make cos squared the subject. So we've got that. So now we've got cos squared theta is half cos 2 theta plus 1. And let's substitute that now back into here. So we've got that. And now let's have a look at this bit here. So we mentioned, or I mentioned it in a second ago, that was going to be sine 2 theta. Well, I know that sine 2 theta is 2 sine theta cos theta. So this one here is going to be 5 lots of that. So we've got 5 sine theta 2 theta. And while I'm at it, I've just kind of tidied up the bracket a little bit here. And now what we've got is the thing in the format that we were being asked for in the question. So our value of A is 12, B minus 5, and C is also 12. Okay, so that's part C done. On we go again. Hence or otherwise meaning it would be a good idea to use what we've just done, but you're free to do something different if you really, really want. Find the minimum value. Okay. So that's the result we had from part C. So 24 cos squared theta minus 10 sine theta. The thing we're trying to find the minimum of is actually equal to this thing here. And it's no coincidence that this thing here, we've got the 12 cos 2 theta minus the 5 sine 2 theta. That's the initial expression that we started off with, and we know that's the same as 13 cos 2 theta plus 22.6. So yet another replacement allows us to do that. And the key idea behind this question is, now we've got it like that, now we can start finding minimum values. On these questions, you're not expected to start differentiating. Okay, there's a much easier way of doing it, and it's just about understanding essentially the cos curve. If I sketch a little cos curve over here, we know, there's my cos curve, we know the minimum value is at -1, and that happens when theta is 180. So we're just going to use that principle, because what we're saying, well, this thing here, the minimum value of this bit, the cos theta 2 theta plus 20.6, the minimum value that could possibly be is -1. So what we've got is the minimum value of the function is going to be 13 times by -1, and then add the 12 on. So the minimum value of that function, the smallest value of that function is ever going to be, is going to be -1. Now, when does that happen? That happens when this thing in the red circle here, when cos 2 theta plus 22.6, when that bit inside the bracket, we need that to be cos 180. So it's going to occur when 2 theta plus 22.6 equals 180. And so now we just need to solve that for theta, and there you go, we end up with theta equals 78.7, and there's our question sorted.